Okay, so we'll just wait 2 more minutes for the others. And have a coffee now if you haven't ate your breakfast yet. At the same time, so we're waiting for the others. This is now your chance again to ask a question. So, any questions so far? Yes, this is how your exam will be like from module 1 to module 6. Okay, so don't you guys worry. Maybe the only the hardest part is only your module 4 and module 6 maybe, and the rest are super simple. Module 1 and 2, I guess you guys will not be having a problem with that. You guys already have an idea on what is digital safety, what is hardware, what is software, what is input, what is output, etc., etc. But for the module 4, so you guys really have to review this one, okay? So that is why I keep on asking you guys, where is that part that you guys are confused? So that we can go back to that part and then discuss it one more time. All right, so it seems that most of you are already here. So again, before we continue our discussion, any questions so far? Any question?
Sir, pwedeng isang example pa po.
One more example of this hexadecimal addition.
Yes, sir.
Okay, so don't forget to put the base 16. I'll just remind you guys that in your quiz, your upcoming quiz is coming Thursday. So yeah, you heard me right. You're going to have your quiz for module 3 and 4 this coming Thursday, next meeting. So you don't need to put the base anymore. Okay, just put the 1e if ever that's fill in the blank, or 1e.0. Okay, so yeah, just remove the base. You don't need to put that one. However, if this one is a written uh, answer or written solution, then this one is very important. Okay, this is an indicator that you have already converted this one, of course, from a hexadecimal to hexadecimal. Okay, addition of hexadecimal. Okay, because if you don't have a unit right here or a base right here, then you will still get an incorrect answer. All right. Okay, so any other question before we proceed to the next example? So are we clear on how did we get this 1e? So it's a direct conversion from here. It's 30 is 1e. Wherein you can actually also do this one. So this is another way of answering things. You can do it one by one. So f plus 1, if you're going to check this one again, f is 15 plus 1 is 16, right? In decimal. But the direct conversion of 16 in hexadecimal is 10. Okay, so from there you can carry 1, bring down 0 right here. But then we have another value right here in e. So 0 plus e is still e, right? And then just bring down 1. And then there you go. You've got the same answer, which is 1e. So you can just actually memorize from 0 to 25. That's already enough. Just, take it or just do it step by step or one by one. Okay. one character or two characters at a time. But if you want to do it three characters at a time, like you've already reached the third portion right here, then you really have to do this one. Okay, so did you guys get this one? Hello? So I'm not really sure if you guys were really able to understand or get this one. So if ever you want to ask a question, so just ask it right now, okay? Don't be shy. I won't get mad.
Sir,
Yes?
tanong ko lang po if ever yung 1E iko-convert sa decimal, hindi po ba confusing kung kasi 'di ba yung 1 separate po yung 1 at E.
Mm.
So parang if I try to convert it to decimal, parang magiging siyang 1 tapos yung E separate, so 14 gano'n po.
If you're going to convert this 1 to decimal, 1e,
I mean yung notation po parang confusing po.
notation? What do you mean
Kasi
notation?
kasi po 'pag sineparate mo yung 1 at E, 'pag kinonvert niyo po, that's 1 tapos yung E is 14 po, 'di ba, sa hexadecimal?
Yeah.
So how do
Mm,
you know po if it's 30 30 or 1
mhm.
tapos
That,
14?
that one depends on the base. Okay, so like for example, in here, we have a base of 16. Oh, ano? Kasi this one will be read as one character, which is 14. And then 1 plus 1 is 24. Or in 24 in decimal is 18. Well, I guess we don't have that kind of question, I guess. Because the one that we're performing here is hexadecimal to hexadecimal. So that's a different scenario if we have a decimal to decimal. Okay. Because if you're going to directly convert this one to decimal, of course you will get 24. Okay. If it's by character. But if it's two character, then you will arrive at 30, of course, right here. So yeah, if ever those ambiguous questions arise, just let me know. Okay, but I haven't remembered putting those kind of confusing questions. So mostly it's super clear. Okay, just like this. You can have this method or the other method, which will give you the same answer.
Thank you, sir.
Okay. So I'm not sure for now, but just in case, just let me know in the future, okay? Any other concerns so far? Guys? Oops. Mali pala yung ginawa ko. Alright, so I guess none. So I'll take that as none. Alright, so yeah, we're having one more example. So let's answer this letter C right here. Oops. So in here we have 19.8 and then AF that 9 plus. Okay, both of them is of course hexadecimal. So 9 plus 8 is 17. Wherein 17 right here is 11. Okay, carry 1, bring down 1. And then 1 plus 9 is 10. Plus F is 15, which is 25 in total. So 25 right here is 19. So 1, bring down 9. A plus 1 plus 1 is 12 since A is 10. All right. So carry 1, bring down 2, and then bring down 1. So in here we have 129.1 base 16. All right. So are we clear so far regarding with example letter C?
Ay, sir, hindi po ba C yung 12?
Sorry. Oo nga naman. So this one should be C because 12 in hexadecimal is C. Medyo malayo na. And C. Base 16. So thank you very much for that one, Miss Eliza. C9, that one, base 16. All right. So are we good so far with example letter C? Or you guys still trying to analyze it? Just familiarize this one. 0 to 9, 10 to 15, 60 to 25, 0 to 9, 8 to F, and then 10 to 19. Right, so any questions so far? Or you guys still need more time to analyze this one? So let me know once you guys are done so that we can proceed to the next example. Okay, so let me just try to ask a random person. Mr. Raven. Raven Gino. Are you there? Okay. So any questions so far? All right. So okay, so I guess that's it for example letter C. So we cannot stay here longer anymore since we don't have enough time. So let's just proceed to the next example. Please let's answer letter D right now. Okay, so in here we have B, that C, F plus 97.64. So of course, both of them is base 16. So F is 15, 4 is, of course, 4. So 15 plus 4 is 19. So it's right here, 16, 17, 18, 19. It's 11. It's quite confusing. 17, 18, 19, 11, 12, 13. So in hexadecimal, 19 is 13. So carry 1, bring down 3. Okay. And then C right here is 13, I guess. A, B, C, 11, 12, 13. I know. So C is 12. Okay. 12 plus 1 is 13. 13 plus 6 is 19. So again, we have 19. 19 is 13. So 1, bring down 3. Okay, decimal right here. And then we have here b plus 1 is 12, plus 7 is 19 again. So 19 is 13 in hexadecimal. And then 9 plus 1 is 10, wherein in hexadecimal it's 10. I mean 8. Okay. So in here we have an answer of A3.33. So were you guys able to follow this example letter D?
Yes, sir.
Okay. So one more example. Oops, mute it. Okay, let's answer this last example. So right here we have BA, that BE, base 16, B plus FAFA. Wow. FA, that FA. Mawas ni Mr. Flores. All right. So E is 14, and then A is 10. So 10 plus 14 is 24, wherein it's 16 to 85. It's ranging from 16 to 85. So 24 is 18. So carry 1, bring down 8. And then we have here f plus 1, wherein f plus 1 is 16. So actually from there we can actually do that also. 16 is directly converted to 10 in hexadecimal. So carry 1, bring down 0 right here. 0 plus b is still b. Okay, a plus a is 10, plus 1 is 21. So 21 right here, 17, 18, 19, 20, 21, 14, 15. So 21 is 15 in hexadecimal. So carry 1, bring down 5. F plus 1 again is 16, wherein 16 is 10. So carry 1, bring down 0. So 0 plus b is b. Bring down 1. And the decimal will be right here, base 16. So it's 1, b5, dot b8, base 16. So were you guys able to follow on how did we answer letter E? No, guys. 15 plus 11 plus 1. 16 plus 11 is 27. So 27 right here is directly 1B, which is the same with this one. So, are we clear so far? Hello? You guys still there? Still analyzing this example?
Yes, sir.
All right, so I'll give you guys 10 seconds, 10 to 15 seconds to check this one. And if you have a question, so feel free to ask me anytime. Okay, so that's good, Mr. Antero. All right, so yeah, that's it for the hexadecimal addition. So let us now move on with, so this is just some sample problems for octal, for hexadecimal, and then some n-base addition. Okay, so I would like you guys to do this one as your practice assignment, and then if you want me to check your answer, so just message me. Okay, the next one right here is multiplication of binary numbers. So I will not explain this one anymore. So this one is the same with, natural, or with how we multiply things. Okay, so 0 times the above, the operand 1, is of course everything will be 0 since you're going to multiply to 0. And then the next one is 1 times the above. So just simply calculate, but you have to move it one character. So 1, 0, 1, 1, 1. And then, of course, the third one will be 0. Okay, since it's multiplied by 0. So this is now the third row. And then for the last one is 1. So you have to copy everything on the top, which is 1, 0, 1, 1, 1. And then right here, just do the math. Okay, so 0, 1, 1, 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 is 10, carry 1, bring down 0. 1 plus 1 plus 1 is 11, carry 1, bring down 1. 1 plus 0 is 1, and then bring down 1. All right, so this might be the easiest, okay, binary operations, which is multiplication. So are we clear so far regarding with multiplication of binary numbers?
Clear, sir.
All right. This one is the easiest. And we have here some exercises wherein you can perform. So just do this one as your practice quiz, okay, or practice activity. And then more examples. So let's move on with sign binary numbers. So in sign binary numbers, this one is just a representation of a positive number and negative number. So yes, we can easily represent positive in binary, but how about if we want to represent negative in binary? So as you guys may all know, in binary, we only have two characters. You have the 0 and 1, okay? So in here, they think of a way wherein if it's 0, then it's being represented by positive side. Like nothing's happened, like the same with this one. So as you guys can see, we have here 1, 0, 0, 1, wherein 8 plus 1 is 9. So that's the equivalence of positive 9. However, if you want to represent this positive 9 to negative, then you have to make the 0 into 1. Okay? So just take note that the one that you're going to make 1 is the most significant bit. Okay? So we have the lowest significant bit on the right side, and then we have the most significant bit on the most left side. Right? So as you guys can see right here, we still have here the 9. So 8 plus 1 is 9. And the most significant bit became 1, just to represent that this one is negative 9. Right? So yeah, that's the idea behind sign binary numbers. However, the computer, okay, has a different method, okay, wherein it is actually using a 2's complement. All right, so wherein we have 3 processes for us to be able to achieve this 1, 1, 1, 1, 0, 1, 1, 1, 1. Okay, so the representation of negative 9 in computer is this one. Okay, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1. Okay, so as you guys can see, this is different from the one that we have before. Well, this is just the idea. Okay, but in here we have another method wherein we're going to use 2's complement. Okay, and then we have here negative 13 wherein it has this binary combination, negative 6 binary combination, etc. Now we're going to try to answer negative 9 for now. And how did we get those 1, 1, 1, 1, 0, 1, 1, 1? All right, so we have this solution. How to derive 2's complement? So we only have 3 steps, or 3 process. So the first thing that you need to do if you want to represent this negative 9 in sign binary, okay, so you must represent it with 8 bits. Okay, so as you guys can write here, this write plus 9 in 8-bit binary. Okay, so this represented in normal way. So in here we have 8-bit, and then we have here 1001 to represent the positive 9. Okay, so that's the first step. The second one is complement each bit, meaning your 0 will become 1, your 1 will become 0. Okay, so 1 became 0, 0 became 1. Okay, and so on and so forth. So just keep on doing that one. Once you have already complemented everything, add 1. Okay, so just literally add 1, okay, on your lowest significant bit. So 0 plus 1 is 1, and then bring down everything. And then from here, you now have the sign binary of negative 9. So if you're going to take a look on this one is the same with this one. All right, so were you guys able to follow? And how did we get this sign binary of negative 9? Hello? So we only have 3 steps. The normal way, complement each bit, and then add 1. And then that is now the result of the sign binary number of the one that you're trying to have a negative sign. Well, guys, are we still okay?
Yes, sir.
So are we good so far? And how to derive this complement? All right. So clear coming from Mr. Antero. How about the others? All right. So clear coming from Mr. Iliota. All right. So just in case, let's just answer a negative 25, letter A. Okay. So our first process is represent this one to the normal binary or 8-bit binary number. Okay, we have here the positive 25. So in here in binary, this one is 0, 0, 0, 1, 1, 24, 0, 0, 1. There you go. So we have 8 plus 1, which is 9. And then we have here 16. So 16 plus 9 is 25. Okay, and then the next thing that you need to do is apply 2's complement. Okay, 2's complement. So 0 will become 1, 1 will become 0. So 1 will become 0, 0 will become 1. 1, 1, 1. All right, and then the last step is plus 1. Okay, so may sagot na tayo. All right, very good. So 0 plus 1 is 1, and then the rest will just be bring down. 0, 1, 1, 1. Right, so from here we have 1, 1, 1, 0, 0, 1, 1, 1. So let's see if you have, or yeah, you have the same answer. All right, so Mr. Antero is correct. So very good. So that is how we represent this negative 25 in sign binary number. All right. So let's now move on to the next one. So here are some of the other examples wherein it already has an answer. Okay, and then more practice exercise. So just answer this one, and yeah, you can message me if you want me to check your answer. All right, and then we have here the character representation wherein it's actually in Ascii code, wherein this Ascii is abbreviated as American Standard Code for Information Interchange, wherein this is what they are using, or this is the standard okay, wherein it's being represented by 128 characters, 7 bits required. Okay, so what are those characters containing? Could be control characters wherein non-printing. So when I say non-printing, could be your windows, like this one, the one that I'm pressing, could be Alt, could be Tab, could be Caps Lock, Shift. And then for the printing characters, so those are the letters A, B, C, D, 1, 2, 3, 4, and then other symbols that you can print. Okay? So punctuations are also included, of course, right? And then here is the ASCII code, or the list of ASCII codes. So in here we have decimal, we have hexadecimal, we have octal, and then the character. And then their definition or meaning. Okay. So as you guys can see, decimal is ranging from 0 to 127. Okay, and then they have their equivalent, a hexadecimal. Okay, so you can find here the, let's say 30. We have here the 1E. 31 is 1F in hexadecimal. The same with octal. Okay, it has the equivalent value, 31 in decimal, and in octal it's 037. All right, and the characters and their meanings. Okay, so we have cancel, shift, backspace, etc. etc. So this one is the complete version of the characters in our keywords. Okay, and then here's one exercise. We're in, yeah, we're not going to do this one since we don't have enough time anyway. Anyway, if you want to do this one is quite fun also. And we have here binary storage and registers, and then their definitions. So I'll leave the reading part to you guys. We are very straightforward. And we have here the, or how transfer of information with registers really happen in our computer. So as you guys can see right here, we have the keyboard wherein have type JOHN. And it will be passed on to our ELU, okay, or arithmetic logic unit, or the control. So each character or each letter is being represented by each cell. Okay. So in every character in our keyboard, 8 cell is already enough. But if it's, let's say, a big data, maybe 16 cell, 32 cells, and so on and so forth. But 8 cell in here is already enough. So we have 4 cells in total actually. So JOHN. Okay, it will be processed as a number wherein, of course, those 8 cells containing a binary combinations. Okay, so as you guys can see, if I press J, our processor doesn't read it as letter J. It will be converted as binary and then will be transformed into a certain letter in our monitor. So this is the representation number of N, representation number of H, O, and then J. So this is what being registered to our memory. So it's a bunch of zeros and ones. Okay, a lot of binary numbers. And then this is how operations work in our computer. So you have the operand 1, operand 2. So if you want to add this one using addition, let's say 225 plus 66, then it will be processed by our processor, wherein it will give you this binary number, wherein this one is equal to 291. So yeah, it will be added as binary, but it will be outputted to our monitor as decimal. All right. So yeah, that's it for module 4. So you guys have any questions so far? No question or clarification? No, we will not meet on Thursday. Actually, this is already our last meeting for the midterms. Why? Because the module 5 and module 6 are more on a self-study. They are self-explanatory module. So it's more on definition. Okay. So I'll just upload the module 5 and 6 later on. And then of course we're going to have a quiz on that one also. So that will serve as your last quiz, 5 and 6. And yeah, your midterm exam, as far as I know, it is, okay, so let me just check. So your midterm exam will be on 18, 19, 20. Okay, so right now is 9. So you guys still have 1 more week. So for this coming Thursday, this coming March 11, you're going to have the quiz on module 3 and 4. And then at the same time, I'll be giving the module 5 and 6 on this Thursday and Friday. So you're going to review that 5 and 6, and then this coming Monday or Tuesday, you're going to have a quiz on those 2 modules. A total of 4 quiz, including the module 3, 4, and then 5 and 6. Okay, so 4 more quizzes before your midterm exam. Okay, and yeah, and then just check your module if ever that I will put here. Let's say 1 more case study for that specific module. So just answer that one. You just keep on checking for the case studies. And then for the lab 6, you're going to have 1 more laboratory, okay, for this coming last week or this coming next week. Okay, so that would be your lab number 7. So any questions so far regarding with your lab 5 and 6? None? Okay, so the last one will be your lab 7. Okay, and then 2 more modules. And then yeah, that's it for the midterm topics. And of course, the coverage of your exam will be whatever is the module from the start and then up to the last, and that are the topics that you're going to review. All right. So yeah, we are already done for the midterms. Any other concerns? Question, guys? Okay, so again, I'm very approachable. Okay, just ask me anytime if you guys have a question or clarification, okay, on any of our topics, quizzes, laboratories, etc. Right? So, okay, so that's it for today, and good luck in advance for this coming midterm exam. And yeah, goodbye, and thank you guys for coming.
Bye, sir.
Bye,
Thank you,
sir.
sir.
Bye.
Thank you, sir.
Thank you too.
Thank you, sir.
Thank you, sir.
Thank you, Ben.